Hi, my name's Gary Taylor, and in this video I want to talk about mass transit and exception handling. It's important to note that I'm not an expert in this. It's just one man's journey, experimenting and playing about with mass transit, getting to know it a little bit better, and just sharing that journey with the community in the hopes that it's useful. Once I am comfortable and I've reassessed everything that I've done within these videos, I'll be doing a masterclass and backing that up with evidential research and things that I've done to make sure that what I say to the community is in fact correct. Now, it's important also to note that I'm not exactly a rookie or an amateur. I've been using messaging systems for uh, 10, 15 years in some of the largest production systems and doing quite well in doing so. But this is the way I learn. This is why it helps my teams, and I share these videos with the community in the hopes that they're useful. So, exceptions are the typical C# exceptions or exceptions that you find in very common programming languages. They can be raised when something unknown happens, a buffer overflow, a stack trace problem, some exception that's occurring. And these exceptions can be out of the blue. You may not have known that your system could actually throw that kind of exception. The next one is the known errors. So you know that a network fault or a particular exception can be thrown from some code. Um, Really strong in programming language like Java, where it declares the type of exceptions that could be thrown from a particular method and allows you then the opportunity to catch them gracefully. And natively, the idea is to either log that particular message, but most importantly, to choose the execution stack to complete next. Do we want to carry on or do we need to roll back this whole process? Is one exception or one particular problem in this block of code? Does it need to roll back everything that's particularly happened within the code? That's vitally important with messaging services that we're talking about here with things like RabbitMQ, because if you have called or published 20 different events and only one of them fails, how are you going to get back to that level of consistency? How are you going to detect that an exception has occurred in the first place, and how is that going to be raised up? So we're going to talk about that more in this. Now, the next bit for me is whenever there is an exception in the system, obviously you want to log that. So you want to be able to make sure that you've got your own logging attributes in there. You're using an appropriate logging package. Example here is Datadog, but you can use any logging package that you want, of course. But it's important that any errors that are being raised are trapped, captured, and stored for you so that you can monitor your system and make sure it's healthy. So let's dive over now to MassTransit's page and let's talk about a little bit about exceptions and what we've got on this page. So the first thing we dive into is to explain what I've said is, stuff goes wrong, bad things happen, and there is no piece of code that is safe from exception, especially anything that is doing any network, database, or even trying to connect to RabbitMQ itself can be challenging if you've not clustered it. So here we can see a consumer, and of course, this is going to error every single time. It's going to throw a new exception, and the producer may not know that that's even happened. So how do we solve this problem? What if we have got some vital piece of work here that's part of a transaction, and in other words, a sequence of events that must either be done successfully or rolled back? How would we go about doing that? And let's make this even simpler. If we are calling a third-party API to add a testimonial, let's say Google testimonials, and it fails, is that it? Is the business happy with the fact that 1 in 10 just won't actually go out, or do we want to retry? Now, as it happens, MassTransit's got a lot of really nice features built in. And these features are designed to help these particular events. So for instance, if we're having a problem connecting something, we have the ability to retry. So let's have a look. We can have a system that maybe makes a connection to a database or some external system, and it's trying to get customer data back. We're expecting a customer to come back here. Well, they say they're an ADO exception, but realistically, it could be lots of different kinds of errors that could come from that handshake to the database to grab the data and to produce some tangible objects that can be worked with. So at this point here where we're getting this data, anything can happen here, and this is within a consumer. So it's possible that this consumer just simply won't finish doing its job. So an interesting part is we've not got any try catches. It's important to notice that, this is just pure clean code. If this raises an exception, then the mass transit transport layer is able to understand and capture that. And we can put rules in, or you can put rules in, to actually retry if there's a failure. So if we have a look at this, and we'll look into this in more detail as I start working through an example. We have a bus that we've created that understands RabbitMQ. We specified the host. That's not really needed. Localhost is default. And then we created a receiving endpoint. So we're going to connect to a queue called submit order. And we're going to bind that to a consumer. This is all standard code, but I will run through this as we go through an example. The piece of pie that we're interested in is this here, and it's used a message retry. And what we're going to do is take this retry event and we're going to ask for it to retry 5 times immediately, which means if this fails, it will just keep on trying. There's no delay, there's no wait, there's no staggered delay. It is just try 5 times. So if at first you don't succeed, try another 5 times. I think it's important to note there as well that that would actually be 6 times because you tried once and then you're going to ask it to try another 5 times. So in total, you would have 6 requests to the service. An interesting point to note there is if you've got a retry of say 5,000 and you have a problem with the system, a network glitch, that one of the databases is down, and all of the systems have got this retry policy, then you could actually see a barrage of errors and messages and problems that aren't legitimate traffic flow. They are actually being caused by a retry policy. So be careful with how many times you set the immediate and know that that could cause errors to balloon beyond what's actually really happening in a typical workflow or business as usual system. Okay, so let's give this a go. In order to do this, I'm going to need to have a bus. I'm going to need to have a consumer, and it's going to need to throw an exception so I can test that this is actually mediating out. Okay, so I've got a helper because I'm lazy. So what I want to do is create a new project. I'm going to call this Mass Transit Exceptions. Go into it. Code. Yeah. Code. So let's open it to a terminal. I've noticed it started using PowerShell as the default. Ugh. Go away. Okay. .NET build. You never know. Well, so I'm doing that. I'm just going to go get Mass Transit because, of course, that's what we would need. And I want Rabbit. Now I always put the version numbers when I'm doing working examples because I hate it when I watch something 2 years later and it's still interesting, still valid, but actually because they didn't specify the versions, the code's moved on so much that you actually can't tell that's true anymore. Let's see what I win with that. So if I go back to the code, what I'm doing is session factory, create session. Don't think I need that. Let's just create this bus and so let's see what we win. That's going to be in main. I don't think we need the local host, so I'm going to take that out because it's by default. So let's take that out. Don't know why I've not got any squiggles for that because that doesn't exist. Sometimes IntelliSense is not my friend. So I need this consumer. So I think that was up at the top. Yeah, submit order consumer. I don't want that one. I'll take this one because this is the one I want to show is erroring. Okie dokie. Let's go in here. So yeah, this handles submit order. I don't want session factory. In fact, I don't like that entire way of registering a consumer. I don't need the session factory. Of course, if you're going to pass in a constructed session consumer, then you need to use that way of registering a consumer. I've done a video on consumers, so just have a look at that for the different ways of registering consumers. Because I'm going to make a consumer that doesn't take anything, I don't need to bother with passing in or dependency injecting in or whatever way we want to call it, the actual property, the session in this case. However, it does have type of submit order. We don't have that interface. So if I go over to something I prepared earlier and then put that in, the event contracts is just a simple C# library project that's designed just to hold the interfaces. So if I build again, hopefully it's included that package and it'll be good. So let's just reload this. F1 reload. See if we can give it a fighting chance. Now, obviously, I need the namespaces in there. Yes, let's include them in. Of course, I want that. I want to be able to build stuff. So, of course, I need using MassTransit. Submit orders, that's actually in my contract. So, I'll be using that. And if we have a look, the submit order, we should be able to go to it now. Just a basic interface that exists in this events contract. You want to name that something really good. You want to name that business domain driven, so that you know your name of your company, name of the department, name of subdomains or the domain that's in, and then subdomains, and keep on going down through the hierarchical business tree because these become your business events that will occur. But it's just an interface that holds data. Tasks, so I'm going to need to include tasks in. Oh, I've messed with it. Yeah, consume needs to be given the thing that's being passed in. So that's going to be a submit order. Let's go back. I think it's context. Yeah, consume context, submit order. Silly me. because we were passing something in there, and I was expecting it to be passed in. It just ends up getting dependency injected in somehow. I thought it would go into the all right, okay. Yeah, I talked about that in the previous video anyway, in consumers, where you can pass in objects. So it's just confused me that little bit. Okay, okay. Well, no errors by the looks of it. So .NET build. Let's make sure we build. Okay, so R, which is parameter of the retry, doesn't have immediate apparently. So it looks like that's probably an extension method, because it looks like it's there, R exists. It's of a retry config that we get back from this use message retry. So it's a bit odd that we got use message retry, but we weren't able to call immediate on it. So at this point, it's really tricky. This is the thing with extension methods, is you either know where they are or you don't. How the hell do you go and find the method immediate? Where does it exist? So if we have a look at use message retry and just dive into that, what have we got? Got green pipes configuration. Okay. Let's have a look. So I'm guessing, but I think using green pipes maybe? Yeah. So it looks like green pipes has this extension method. So where you got this, it's an extension method to the retry configurator. It just basically gives it more functionality. So you can see actually there's other ones like immediate, exponential, incremental, intervals. So this is part of this green pipes project that's being used within MassTransit. Okay, does this build now? Yes, we do. I love extension methods, but when that happens, it's a pain. So what have we got? We have got a bus. We're going to create a submit order receiving endpoint, and we're going to consume the message, and the consumer is then going to throw an exception. But one vital piece of the pie which is missing is actually to raise the thing in the first place. We've got an endpoint with a retry, but we haven't got anything that's actually publishing this message yet. So if we go over to producers, I've done a video on this as well, so just check that out. Easiest thing to do is to actually send out that message. And there's a easier way of doing it, which looks very similar to that. In fact, there's like 20 different ways of doing it. Well, there's not 20, but there's different ways of being able to send a message. And I think this type of syntax is the easiest way, in my opinion. So let's grab something like this, and let's see if we can use this. This is where we have the fun, don't we, of understanding. So of course we need it to be public static void async. No, public. Come on, fat fingers. Service address. I want this to be a queue. Submit order. And then submit order. Oh, yeah. I've not got a class for it, so if I do send that, and then you that. Okay. So to start again, I've had to create a public async task, so you need to AO8 a few things. We've got a bus, bog standard stuff for creating a Rabbit bus. We've created an endpoint which submit order, which should create the exchange. Yeah, should create the exchange. And then we go through, we try this retry, and then we consume it. So we set up a consumer. So this is going to be consumed by this. And then we'll set up an endpoint to send to the queue, and we'll submit and we'll send that. In doing the send, it'll automatically create the queue and set up the binding for the queue. So we should have something fully working here, hopefully. So if I do .NET Run, what I'm hoping to see is six exceptions in rapid fire if I was actually producing anything to the output. So let's try that again, shall we? Console, right line, hello from consumer. Jeez. It is Sunday morning. Okie dokie. Ah. Okay, this is finishing straight away, isn't it? This is actually going to run to here, and then the program's going to terminate. We're going to send. We're going to await. It's going to send, but then it's going to die. I'd be interested in knowing whether this even actually is hitting RabbitMQ properly, because the program is just dying instantly. Got RabbitMQ running, so I've got my exchange now as I'd expect. He says submit order. Yeah, yeah, traffic's going through. It's going to submit order, and submit orders there. Is there any messages in submit order? Yeah, there's 2 ready. So they're not being consumed because it's just finishing before the consumer's had chance to pick it up. We're sending it and then just finishing. So we have to get this program to wait and just allow the program to continue running so that it has a fighting chance of doing its work. So in previous examples, in previous ones, I've just had a do while forever. Well, just a while actually, it's not even a do while, just a while here. And we're running and it just asks for input. Well, that stops the program from stopping. There are obviously more elegant ways of doing that, but for this, I think that should work. So we run, we've not stopped, but it doesn't look like we have hit the consumer, because I would have expected to see some output from this. Now let's just make sure that I'm not going crackers. So yeah, we're starting, and it looks like the consumer isn't working properly. So we've submitted an order. If we go to RabbitMQ, you can see that values are going in. Well, I say we can see. Let's double check. Let's get the messages. We can see messages going in, and that is from event contract submit order, and that's what needs to consume that message. So event contract submit order, and that's the queue for submit order. What I am going to do is there's no correlation here. I mean, this says here's the consumer, but it's actually not saying what type of message it's responsible for consuming. So I really don't like this newing of a consumer, especially if we don't actually need to. Oh, that's the type, not the consumer. So receiving endpoint is submit order. So that should be the queue. We're going to consume that. So let's try again. Nope, nothing in there. I'm just going to purge this queue. Get all the messages out. Okie dokie. Got this exchange. We got submit order. We have submit order queue. That's going through here. Okay. Go in. There's currently no messages. Let's stop this. Fire it up again. A couple of seconds. Should refresh. I'm expecting to see something come in. So there's a single message that's come into the submit order. Oh, have I got a connection? Yeah, well, of course I have, because I've connected to it as I'm producing. So this consumer just isn't understanding this submit order. It's not registering to it. But I'm not getting a skipped or an error. So what have I done wrong? I haven't done anything wrong. Couldn't possibly be me. I think I know. Bus, create bus, center bus. Let's never start it or stop it, eh? That would be a silly thing to do. Why bother starting the bus? So now that I've got my bus, I need to start it, otherwise it's not going to do anything. I should also stop it as well. Down here, I think we can just do dot stop. I think. Okay. Because I swore it's just stop. Let's just do traditional just for now. Unreachable. Why would that be unreachable? Anyway, let's give it a go. .NET Run. Great. So we get hello. We got 1, 2, 3, 4, 5. Oh, hello from consumer. So yeah, starting 1, 2, 3, 4, 5, 6. So we got the ability to do. We pushed it, we consumed it, and as we were consuming it, it errored, and then we said, right, I want you to try 5 more times. So an interesting point here is if I was to just say try one more time, of course we would try twice because we would try the first time, it would fail, and then I'd ask for it to be done again. So we could then see 2 that's coming through. So that's pretty cool. Now if you was to do something silly like 20, I don't know what the actual limit is on the immediate, but that would try 20 times. Now, if you've got a service that's down or has got a real problem like a network problem, a database is offline, then just simply asking for it to retry and retry and retry over and over again would be silly. So just be careful with how many times you do that. If this is also logging, or generating something or doing something, you might find that some of this code is working and then it throws an exception. So you're going to find yourself in a bad state. You're going to find yourself where the promise of eventual consistency will never be true, because if this is adding items into a warehouse and then we're dispatching them, well, if the bit that adds the item into the warehouse is running, but the code that dispatches is the bit that throws the exception, if you've not chained these things together correctly, this retry can make you have a very bad day. You can end up filling your warehouse up with stock that you're never going to sell. So let's dive back now, shall we, to exceptions. So this was the retry. This was pretty simple once I got produce and consumer up and running. Apologies for that. There's different types of retry policy. You noticed in when I was looking for the library, there was the extension method for immediate, which so happens to be in this green pipes project. There's things like incremental, intervals, um, none. Why you would have a retry policy of none, I don't know. So let's see if we can play about with one of them. Let's look at retry after a fixed delay. Okay, so interval. So look. So interval 10, and then from milliseconds. So my guess is try 10 times with a gap of 200 milliseconds between each. So let's have a play about with that, shall we? No. At least try and read the code, Gary. I think 200 milliseconds is very quick for my brain, so I take it to half a second. Oh, come on, Gary. What have you got? Oh. I apologise, it is Sunday morning. So I'm expecting this to happen 10 times with half a second between each. That felt about right, but let's try 1,000 because it's easier to be able to visualize that. So here we see it. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and so on. So you can see that's every second. If you ever want to count a perfect second, don't try the elephant, just try the 1, 2, 3, 1, 2, 3 as a marching band. There we go. So that was working. What was the other one? We had exponential. So if that should go up, doubling each time, if I remember my maths. exponential. Not quite sure what parameters that should take. Int retry limit. Retry limit, let's try 5. Well, 5 what? Creates an immediate retry policy with a specific number of retries with no delay. Oh, that's immediate, idiot. This one. Retry time min max interval delay delta. Okie dokie. I'm bitten off more than I can chew here. So what have we got? We have, let's let IntelliSense be our friend. We have int retry limit. Let's try 5. Time span min interval. Well, let's go for 200 milliseconds. Time span max. Well, if it's 5, if we want to go up, we would probably want, say, 5 seconds. Now let's go for 10. 1, 2, 3. 10,000. So that's 10 seconds. Interval deltas. I have no idea. IntelliSense wasn't my friend then. So let's see what we get there. Okay, okay. I think it was going up, but it was a bit too quick. So if we have 10 retries and the max is that, I think the delta is how much it's incrementing from. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah, so it's incrementing by that with each delta, with each clock tick of the retry, we're going up until eventually the biggest one will take 10 seconds. Once again, be really careful about this because your message is kind of in flight. It's kind of waiting to be processed, but not. Someone pulls the plug on RabbitMQ. What's happening here? And it can also make any kind of logs look very weird as you get a request that's coming in that's just gradually increasing or decreasing with time. However, I think it is better than retrying 5 times in a row plus endlessly. If you've got a network problem, if you retry again instantly, you're probably going to still have that network problem. So have this kind of exponential retry. It feels safe. This probably is a little bit too much. However, it just allows us to see visually what's going on. So that's pretty nice. Then retry after a steady increased delay up to limit. Right, so that's just a small increment. Then you've got intervals, which allows you to specify your own block. So, this is going to try from 5 minutes to 15 minutes to 30 minutes. I wouldn't recommend that. Holding something in flight or on hold for 30 minutes doesn't feel quite right, but I'll explain it when we get to this bit here. Okie dokie, so we have got retries. So exceptions, we can configure that. So the next bit we want to talk about is exception filters. So there are certain errors that we can get that we don't need to retry. If you consider you're trying to insert some data into a database and you'd get a truncation problem, the data you're trying to put into the database does not fit. You're asking to put 30 characters in, it supports 10. Doesn't matter how many times you retry, until that database has been updated to support that amount of characters, which is not going to be done in the 5 seconds it takes for the retry, then there is simply no point in retrying because it's going to continue to fail. So at that point, we can actually put filters in to ignore some error messages. So if we look here, we can ignore different types of exceptions, so invalid operation exception, or we can ignore arguments where there's a parameter of a particular value. So that's really strong, that we can see a parameter and we can say if it equals total order, then ignore it. Here we're looking to see if it contains SQL. You want to clean that up a bit, but I get the sentiment in that if there is like a truncation problem, you don't want to retry. It's going to continue to fail. If the arguments are invalid, it's going to fail. But if you get a network timeout error or some other kind of, I think they call it ephemeral, I'm not sure, some kind of error that isn't long lasting, it's just a temporary blip, I should say, then it's good to retry. So let's see if we can play about with that. So I'm going to play about. What I'm going to do is I'm going to create an int error ID get, and I am going to not here, honestly. Publish, where we publish the message. Send order ID error ID equals 1. Just double check I've got that right. I generally do this casing. Yeah. So if context dot message dot error ID equals 1. In fact, I should probably switch it. And then throw new invalid operation exception. Boom. So I'm going to pass a value in, and if I pass in 1, it's just going to throw this exception. Otherwise, it's going to throw this generic exception. In fact, let's just change that. Let's just say console.write. Everything worked. I don't know why I try and correct my spelling when I'm doing a demo. It doesn't make any difference to anyone if I spell it right or wrong. Okay, what I'm going to do is just change the interval as well. I'm going to take that, comment it, and uncomment that. I'm just going to try 5 times, just to make it obvious. Let's run it. So we tried 5 times there, and that's because we passed in 1. If I pass in 0 and run it, everything worked as we'd expect, because we just run into this. So what we can do is we can choose to ignore particular exceptions. So if we have a look at this, where we've said 1 and obviously that exception is going to be thrown. And therefore, we're going to try 5 times. Yeah. What we should be able to do is to use the message retry policy. So this is this. So we want to drop this down and make it a real boy. Then we want to ignore the thing that we want to know. Ignore is invalid operation exception. So now when we run this, it won't retry. Of course. So it didn't work. In other words, we didn't get to the line that says everything worked because the exception was thrown, but the exception was just put to one side and ignored, which can be dangerous because what does that actually mean for the queue? Well, let's double check. We can see an underscore error, which I'm just going to purge so we can see that. And in consumers and producers, we talk about the underscore error queue, but just to give a iteration, there 0 messages at the moment. If I end this and run it again, we run. We didn't get a success, but we didn't retry. And does the message end up in the error queue? Yes, it does. So there we can see my message. Get message with an ID of 1. So that went into the error queues. Interesting. What I want to do, delete purge message. Is just double check the retry policy. So what I'm going to do is I'm going to ignore this ignore. This will do the retry. But what I'm going to do is I'm going to do an interval. From seconds, 1. So I'm just going to wait 1 second, but I'm going to do it 5 times. If I go into submit order and order error, there's nothing in there. So let's give this a run. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and into submit order it goes. And it didn't actually find its way into, oh, and there it goes into errors. Okay. So that was interesting in the fact that we could see that it only went into submit order once it had been processed the 5 times, and then we decided, oh, it's going to error, and then it went into errors. It's something I noticed when I was looking at schedules is that it kind of holds things in the exchange and processes them there and then pushes them through from the user interface's point of view. So that's something I'm going to cover more in later detail to understand that how messages are actually held in exchange. So that's pretty cool. We can ignore that, but we can also extend it, I believe, to say, you know, if the message equals boom, then we ignore it. So even if an invalid exception occurs, then actually we'll ignore that. Now, because number 1 is throwing exception and it's going to run boom, it should ignore it, and it does. If I change that to something like tick tick boom, well, that message doesn't equal tick tick boom. It is an invalid operation exception, but it's not that particular message. So we do actually retry. So that's pretty cool. That allows us to gracefully handle stuff that we know are legitimate errors that we can ignore. Things like truncation errors and things like that. Right, so the next part is about redelivery. This is a bit more serious. This is where messages aren't in the queue that are held and they're processed for redelivery at a later date. And we can use a scheduler that allows us to take messages and say, I want you to re-deliver them in, say, 30 minutes. Now, you shouldn't use an interval, just a standard interval for that. You want to use a scheduled redelivery platform. And whatever service you're using, whether it's RabbitMQ, you need to make sure that that service has got the appropriate config or plugins to support redelivery. I'm not going to get into this in this chat because I just want to talk about exceptions. And in my opinion, redelivery is a bit more advanced than just dealing with exceptions. So I'm going to cover that in another one, in another video. Um, Similar with outboxing, I'll cover that as well, but this is just taking that message and holding it somewhere else for a bit of time. So another interesting concept that I'll finish up on is dealing with faults. I think this really does lie in with the exception handling, is that of course messages will be sent to underscore error. If there's a particular problem, they'll be held in this underscore error. But there are also raisers of an event called faults, which has this underscore faults syntax. And we can actually subscribe to that by using a faults consumer that can accept that message. So what I'm going to do is just take this and just put it down at the bottom here. And just take that. Something went wrong. So what I'm going to do is I just want to call it something better. So the name's irrelevant, but it's the name of the consumer. Implement the iConsumer interface, but we are going to say that we are going to have fault of type submit order. So when a submit order fails, sorry about that, when a submit order fails, it should be consumed by this. However, I believe we still need to register the puppy. I don't think we're going to get this for free. It still needs to be attached. So if we have a look at the way that we're attaching this, we've got receiving endpoint of submit order and then consume submit order. So I think we're going to need another receiving endpoint. So submit order underscore error, fault. And obviously this needs to be in the config. We'll config as scope. Oh, why do you do that? It's like JavaScript. So e.consumer submit I thought it was could submit order fault. What did I call it? Doesn't help if you can't spell. So we're waiting. I'm going to do this one just so that we can see things. So if I run this, so 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, boom, something went wrong. So something went wrong came from the submit order fault. Now notice that my message is still going to be in the error. It's still going to be kept and held for us to review and look at and make sure that everything is great. Well, sorry, to replay that message and allow the ops team or dev team to look at that and go, this is the message that generated the problem. The fault allows us to do things like roll back, have that eventual consistency. If we know that there's something in there that adds an item to the warehouse, then maybe a fault in this process should action someone to just double check that the warehouse is okay. Or maybe if we know that this is true, then the fault will actually revert back that ID, from the submit order. We have the order ID. We know what products have been delivered and asked to be put into just-in-time processing for the warehouse. This is how companies make money now. They don't want products, thousands of products sat in a warehouse waiting for the opportunity of a customer to buy one. That's just wasted money on inventory that is depreciating over time. They need just-in-time delivery. So if they're doing well with a particular order, they might over order by 1,000 or under order, and that process will, when we're submitting the order, it will instruct for us to double check, do we need to increment that? Do we need to buy more for the warehouse? Here, if the payment failed or something happened with delivery, that we weren't able to deliver it, shortage of staff or whatnot, then we might as well undo that order for the warehouse. That can be done within faults. We can make sure that eventual consistency remains intact by dealing with it here. So this is a really nice way of seeing that, right, we tried 5 times, we were throwing exceptions, we knew the exception needed to be managed, we therefore retried, but we couldn't do it. There's some particular problem processing this order. Therefore, I want you to raise a fault and then roll back on other messages. And data can be added and changed as it sleeps or gets pushed through this pipeline of event messaging. This is where we start to get really into event messaging driven platforms or a domain bounded context where you need to chain and look at how workflow occurs. If you go into Kafka, where you can understand how messages are grouped together and form other messages and either complete in entirety or roll themselves back, you can see how you can use a mechanism like that for doing this at a primitive level. So it kind of talks about this, and I'm not going to go into state because Sagas is one of the next ones that we'll be covering. So we'll talk about state management when I start going over Sagas. But as I just said, data can be pushed down through a series of queues, and that can all be related to a particular thread or correlation ID, and data can be manipulated and changed as it moves through that. And because of that, you also want to make sure that faults understand how to solve that problem. We have the ability to discard any fault messages or any error messages for that matter. So anything like underscore errors can be moved to faulted messages. Don't know why you would do that, but this library is extensible to allow people to do things. And we saw in previous examples that if you're not consuming that particular interface, then things can be moved to a skipped, and you can choose to ignore that if you would want to. I would never would, because I think it's a great way of making sure that everything's set up and that you've got consumers consuming them interface types. So it's there in case you need to use it. I don't see that I ever would. So that comes to the end. So as a big recap, let's scroll right to the top, shall we? We looked at exceptions, how they occur within a consumer. It took me a long time to set up a publisher and a consumer. I'm really sorry for that. It is Sunday morning. We looked at different mechanisms for retrying when an error has occurred. And we saw that there was a multitude of different types of retry policies. You can also roll your own as well. You can build your own and add that as an extension method, of course. And out of the box, we get the immediate interval, intervals, exponential, and incremental. If you've done a bit of maths, all them things kind of make sense. We can choose to filter, ignore, or include particular types of handles. Particular types of exceptions. So we can choose to handle them or ignore them. And we can even drill down into messages and, write a Lambda statement that will actually query that. And if these conditions are true, then it will accept it. So it gives us great power to actually see what's going on. Here's an example where it says if it contains SQL. Now, obviously, this is just an example. You really want to look at the error messages that you're getting within your logs and take real care in working out whether they should be ignored permanently. And make sure that you do that with your Scrum team so that everybody understands and has the ability to vote on whether that should be ignored. Please, as a developer, don't just go in and say, yeah, I'll ignore that message and don't tell your team. Things like this need to be handled with care because some of them error messages may look like they're permanent, they're always going to reoccur, but it's vital that you understand the system and understand what the error messages are and build an expression that is as concrete as possible and doesn't have the opportunity to be swallowed up by another message that just so happens to fit these two conditions. It was a data exception and it did contain the SQL statement SQL. If you've got development teams who are messing with messages and try catches, then you can't guarantee anything. So just be really careful with that. It went on to redelivery, which is kind of the ability to hold something and schedule for it to be redelivered. That took me a long time to get my head around properly, and I'll be doing a video just dedicated on that next. So outboxing, sagas, that'll be covered in the next video. And finally, we looked at faults. We saw that anything that goes to underscore error also raises a false via a publish message, and we can accept that and use that to do any cleanup. What you might normally do in a finally try block or something like that, you could actually implement cleanup within this consumer. Or sorry, what you would do in your normal try catch, where you might roll things back transactionally, you would do that, not in the finally block, obviously. So that's part of catching the faults. And that comes to the end of this. I think we're just on an hour. So thanks for watching. If this was useful, as always, try to hit that subscribe button. And cheers. Thank you. Bye.